Elimination with multiplication. It's our next step through our elimination technique. Very similar to what we've been doing, but what we're going to find today in all of our problems is that none of our letters are going to have equal and opposite coefficients. We're going to have to make them all equal and opposite if they're not already there. Step number one with elimination is still to have everything lined up vertically. So we can notice that the x's are still over the x's, y's over the y's, equals over equals, numbers over numbers. So we're still good on all of these problems. The problem is we won't have them already found or already made. Our main focus today is to create those equal opposite coefficients. So what that means that we're going to have to do on all these problems, looking at this one right here, is they're already opposite, but they're not equal. All I'm going to have to do is multiply this top one by 3, and now they are equal and opposite. This middle problem, same thing, they're already opposite. If I multiply this one by 3, they're now equal and opposite. This top right one, not equal, not opposite. So we're going to do both of those things. If I multiply this bottom one by 4, I do get the 8, but I still haven't corrected the fact that they're not opposites of one another. So I'm just going to subtract, or I'm going to make it a -4, apologies. The -8 on the top stays as is, but then we get a +8 off the bottom. Now they're equal and opposite. Same thing right here. The 8 on top, 4 on the bottom, they're not equal. They're already opposite signs, so my only move I need to do is multiply by 2. And now they are. These last two examples, this one right here, at least we have opposite. This one we've got nothing. And there's no number that I can think of that's a whole number, rather, that I can multiply 4 and just turn it directly into 6. So what we're going to have to do is we're going to have to find a common multiple that 4 and 6 can both become. So if we write out the multiples of 4, we've got 4, 8, 12, 16, ... And if we write out the ones for 6, we've got 6, 12, 18, 24, ... We're trying to find the first one that they both attain, and that's this 12. So once we find that common number, we're going to change both of them into that chosen number. So to get a 4 to become a 12y, we just need to multiply by 3. And to get the -6y to become a -12y, we just need to multiply the bottom one by 2. This last one needs to be equal and opposite, so at least one of them is going to need a negative. Could be the top, could be the bottom, it's just a choice. And the first number that 2 and 5 can both become is 10. So to make the 2 become a 10, I need to multiply by 5. I chose this one to be the negative, so we get a -10. While on the bottom, I would have to multiply by 2 to get that 10. We then have our needed equal and opposite. So let's take this idea and bring it down to one of our actual problems. When we are solving by elimination, we have two major questions that we want to ask. Are we lined up? Is the very first question. X over X, Y over Y, equals over equals, numbers over number. The answer to this one is yes. The second major question is, do we have equal opposite coefficients? And the answer to this one is no. Because it's no, we're going to go and make them equal and opposite. We just get to choose. Do we want the x's? Do we want the y's? All personal preference. So we come over here. What I like to do to check, because I want the problem to be as simple as I can make it, is I look at the x's first, just because they are first left to right, and I ask myself, what's the first number that 6 and 12 both become later? So I count it out. 6, 12, 18, 24. And then the 12s. 12, 24, 36, 48. And the first number they both become is 12. Do the same thing, but this time with the y's. And we find that the first number that they both can become is an 8. Here's where we get to make our first choice. Do we want the x's to both be 12 x's? Or do we want to have 8 y's? There is no advantage to one versus the other, so we just got to make a choice. I probably, looking at the problem, would make the 6 become a 12. So my choice would be for that one. And to make that top equation become a 12x, I'm going to multiply by 2. That gives me a negative 12x minus 16y equals 28, because this 2 multiplies all 3 numbers inside the problem. The bottom equation did not change, so I'm just going to copy it down. We check. We get equal opposite coefficients, so we're ready to add. Negative 12, positive 12, there's that 0 that we so desperately need to keep moving through this problem. Negative 16 plus 4 is a negative 12y, and 28 plus 20 is a 48. Clean up the problem. We don't need that 0x. So we've eliminated the x. We are now able to solve for y. So we subtract by negative 12, and we find that y is negative 4. So we have half of our answer. To go find our other half, we're going to take this negative 4, we're going to plug it in, and we're going to solve. We have 4 choices. We can pick the original equation, original top left, original bottom left, new top right, or the bottom right. I do understand that these two are the same equation. Still doesn't mean we can't choose either of them. I would choose the bottom equation for the simple fact that there isn't a negative number. So we're going to plug in the fact that y is negative 4. We get negative 16 in that place. We're going to add 16 to both sides, then divide by 12, and x is 3. So elimination with multiplication doesn't change much of what we've already been doing. Instead of just multiplying by a negative here to make it equal opposite, we might be multiplying by a number like 2, 3, 5, whatever we choose to get those equal coefficients. Next one down. Let's answer our 2 questions lined up. The answer is yes. Second question, equal opposite coefficient. No. So let's go do our checks. 4 and 10. You might think the first number that they both can become is a 40, but we could actually get them together at 20 a little bit sooner. Then 2 and 4, the first number they both can become is a 4. We can do either, making the x 20s, the y's 4s. It's usually smarter to pick the smaller option. To make our top equation become a 4, we're going to multiply it by 2. That gives us 8x minus 4y equals negative 2. We did not need to multiply the bottom equation by anything, so we have 10x minus 4y equals negative 14. We go back to our second question right here. Second question. Are they equal opposite? And our answer is still no. We made them equal, but they're not quite opposite. So I'm going to go back in time. I'm going to make that a negative 2, which reverses the signs on all of my top equation. I get a negative 8, a positive 4, and a positive 2. We don't want to rush through this part of it. They need to be equal opposite. The next place we can check to make sure we haven't made any silly mistakes is during the addition. Don't assume you know the answer just because of what's supposed to happen. Actually take a step back and pretend you're looking at this problem for the first time. What is negative 8 plus 10? It's a 2x. Is what you have actually written right here going to become the 0 y's that you think it should? This is where mistakes happen the most for students and people who are learning this technique for the very first time. Is we're so used to creating that 0 for x or for y that a lot of times when we have this negative in front of the 4, we don't see that they're opposite, and we just assume that it becomes 0. That's not the case. This one would become a negative 8. Depending on what happened in the rest of your problem, you might luck out and have like a couple typos that cancel each other out. We want to make sure that what you have written truly becomes what you think it should. Let's finish out this step of the process. 2 plus negative 14 is negative 12. Clean up the equation. 2x equals negative 12. So x is negative 6. Choosing our equation to solve for x or for y, or for y in this case, I'm sorry. We have 4 choices. We can pick top left, bottom left, top right, bottom right. Doesn't matter which one we pick. We want the one that looks the simplest. To me, that is the top left equation. We remove the x. We replace it with a negative 6. We get negative 24 minus 2y equals negative 2. We add 24 to both sides, gives us positive 22. Divide by the negative 2. And y is negative 11. So let's try it with a few more of these problems, increasing in difficulty as we go. Let's do this left problem right here. They're all lined up, so question 1's good, but we don't have equal opposite. First number for 3 and 6 is 6. First number for 8 and 10 is 40. We're not going to choose the 40. We don't need to do anything to the top equation. So I'm just going to rewrite it right now. But the bottom equation, I need to double it. Now, while we're looking at it, we're also going to ask ourselves, are we opposite signs for the x's? And we're not. So we're going to multiply by a negative at the same time. Equal opposite, we're ready to add. We truly get 0x. We get 2y. We get, what is this, negative 12. So y is once again a negative 6. Picking one of our equations, maybe the original, or maybe one of the new equations. Doesn't matter which one. We just make a choice. I probably would pick the original bottom left. It appears to be the easiest. We have 3x minus 10. We're going to replace the y with that negative 6. So we end up with 3x plus 60 equals negative 8. We subtract 60. This feels like it's too large of a number. I feel I've made a mistake somewhere. 2y. That is negative 12, so that's negative 6. Well, we'll come back to it. We divide both sides by our negative, or 3 in this case. Let me grab my calculator. Yes, we've made a mistake somewhere. Where did we? Oh, geez. I see what I did wrong. Okay. Very common mistake. I was wondering what I did wrong. It's right here. This negative 2 has to multiply to all of the terms. I decided that this 10 just didn't matter. It needs to be a 20. Which changes this to be a 12. Which then makes our answer right here a negative 1. Then we can plug in a negative 1, which makes this instead just a 10. Which makes this a negative 18. And x is negative 6. So, always good to check to make sure, did you fully distribute this negative 2? This is what happens when I don't draw my arrows. I forget to multiply. All right, let's jump down. Let's find a good one. Let's do this bottom left one right here. So we are lined up. We do not have equal opposite coefficients. The first number I can think of that 2 and 3 both go into is 6, while the first number for 6 and 8 is 24. We can choose either of those options. The 24 is going to be a lot larger number, so we're going to avoid that. Since we've chosen 6 for the x's, everything we're going to do is to get them to both say at least a 6. To do so, we're going to multiply that top by 3. There's our negative 6x minus 18y equals negative 60. I don't want to cause the same mistake, so I'm going to make sure I just fully distributed. We get negative 6, negative 18, negative 60. Then the bottom equation, I would need to multiply by 2. That gives us 6x minus 16y equals negative 8. Again, let's make sure I did that correctly, unlike the last problem. 2 times 3 is 6. 16. Negative 4. Looks like we're ready to go. We're going to add these two equations together. 0x negative 34y is equal to negative 68. So we break that multiplication by dividing them both by a negative 34. And y is just a simple 2. Solving for x, need to pick one of our equations. I'm not going to pick the two equations over here on the right. They're larger than they need to be, so we're not going to. I'm probably going to pick the bottom left equation because the numbers are smaller and there's one fewer negative. So 3x minus 8 times 2 equals negative 4. So that gives us 3x minus 16 equals negative 4. Add the 16, we get 3x equals 12. Divide by 3, and x is 4. Last problem for the video. I need to make them be equal opposite coefficients. For 9 and 10, I'm pretty sure the first number they both go into is 90. So we're not going to do that. And the first number for 4 and 5 is 20. Still not great, but it's better than 90. So I need to multiply the top by 5 and the bottom by 4 to make it happen. They're not equal opposite, so I'm going to make the top one a negative 5. We could have easily have chosen the bottom one to be the negative. It does not matter. Lots of choice in this unit, lots of choices with these methods. You just got to pick one and go. We get negative 45x's minus 20y's is equal to negative, I believe it's 80. I'm going to double check because I don't want to make any other mistakes. There's our top equation. Bottom equation gives us 40x plus 20y equals 60. We've got our equal opposites for our y's. Negative 5x equals negative 20. So x is 4. Choosing one of our equations to help us solve for y. I'm going to choose this top left one. Smallest numbers, no negatives. So it's as good a choice as any. 9x plus 4y equals 16. Plug in that 4 for x. That's 36 plus 4y equals 16. Subtract 36. Divide by 4. And y is negative 5, making our answer the coordinate point 4, 5. And that is solving elimination with some multiplication.